Continuing looking at lesson 6.3, which is making comparative inferences about populations. We'll look at example 3, page 331. Mr. Bunsen had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the heights of all the plants after 3 weeks. How do the 2 populations compare, and what inferences can be drawn? So, some different observations. First of all, a quick and easy thing to do is look at the medians. Median, again, is right where the 2 boxes meet in your box and whisker plot or box plot. Notice the median heights are the same. So 50% of the plants were taller than 12 inches, 50% were less than 12 inches. We can look at the interquartile range. Interquartile range is again the difference between the upper and lower quartiles, or the third and first quartiles. So here we're looking at 14 minus 8 is how they got 6 there for the interquartile range. That's for room 7D. For room 7G, we would be doing 16 minus 10, which has an interquartile range of 6. So both of them have an interquartile range of 6, so the middle 50% of the plants is spread out just the same in both cases. If you notice this though, which room has the tallest plant? 7G has one plant that grew to 20 inches. 7D, the tallest plant, is 18 inches. Which room has the shortest plant? 7D. Okay, so with those 2 things, the tallest plant overall, and then the one plant, or the one room has the shortest room overall, might lead us to conclude then overall that 7G has a little bit better growing conditions than 7D. So we look at the try it. A local recreation center offers a drop-in exercise class in the morning and the evening. Attendance data for each class over the first month is shown in the box plots at the right. What can you infer about the class attendance? So we look at the class attendance here. Let's look at the medians real quick first of all. That's an easy thing to check. Which class had the greater median attendance? Evening, good. Evening looks like 6.5 hours. Morning, 4.5. Or actually, not hours, that's how many people were there. And again, that's an average, okay? When you average stuff, it doesn't always make sense. Which class had the highest number of attendees at one point anyway? Evening, good. Evening, the most they had was 12 people. Highest the morning ever had was 8 people. Okay? What about the fewest numbers for each of the classes? Okay? Morning had the fewest overall. 2 people versus 3 people. Okay? So what we're going to do here, we're just going to make a general statement off of this and kind of just talk about which class it looks like generally had more people would be evening. Okay. So here could be a statement we could make. In general, attendance was higher for the evening class. Again, doesn't have to be some kind of groundbreaking discovery that we're making here. Just a statement of the obvious, maybe. This problem did not ask us to find the interquartile range. If we would do that, interquartile range for both of these would be 3. So the middle 50% is the same variability or the same consistency for both classes, we could say. So key concept, just kind of recapping some things here. When we look at box plots, we can make some comparisons, informal comparisons. Here the book talks about. For this one, looks like the medians are the same. We can look at what the interquartile ranges are. So interquartile range for set A, 7 minus 4 is 3. Set B, 9 minus 4 is 5. So a little bit more variety for that middle part, that middle 50% for set B. Besides that, we can even look at the whole box and whisker plot. Okay, and this is just a note I made here. Interquartile range is bigger, so we know the middle 50% of the data is more spread out. But we want to look at the overall as well. Okay, so set B, middle 50% is more spread out. Overall, we look at this for the range, overall range. Set A, we would do 9 minus 2, has a range of 7. Set B, 10 minus 1 has a range of 9. So besides the middle 50%, even overall, data set B is more spread out. Okay, more spread out, what we can say, two ways of putting it, we can say, well, you could just say it's more spread out. Usually they'll say it's more varied or it has more variability. We can also say it has less consistency. Okay, if you're consistent, that means you pretty much, not always, but you're pretty much usually do the same thing. Less consistent means we don't really know what's going to happen. So more consistency, less variability for set A than set B there. Do you understand number 3? Two data sets both have a median value of 12 and 5/10. Data set A has an interquartile range of 4. Data set B has an interquartile range of 2. How do the box plots for the two data sets compare? So if you'll notice, the medians are the same for both groups. Interquartile range is what's different. So interquartile range is 4 for set B, or sorry, set A, it's 4. Set B, interquartile range is 2. So from that, we could conclude something like this. The box in the box plot for data set A is longer, or you could say wider, than the box in the box plot for data set B, and that's how the box plots compare. If we wanted to actually talk about what that means for us, we could say that set A has more variability. Okay, more variety in the numbers. Well, we'll modify for the middle 50% anyway. Overall, we don't know, but middle 50%, more variability, or you could say less consistency for set A in the middle 50%. Numbers are spread out just a little bit more. So look at the do you know how. We have box plots describing the heights of flowers selected randomly from two gardens. They want us to use the box plots to answer the next two questions here. So they want us to find the median of each sample. So if we look at our box plots, so we look at garden Y. right where the two boxes meet, that's our median. So garden Y, you'd say the median is 6 inches. And garden Z, median would be 4 inches. Okay. Number 5, they want us to make a comparative inference about the flowers in the two gardens. And again, doesn't have to be anything real crazy that we're coming up with here. Just an observation. And like we did earlier, if you want to just say in general, this garden, the plants are taller than the other one, or the flowers, that's probably good enough. So looking at this, look at the medians, look at the tallest flowers, look at the shortest flowers. Shortest flowers are the same, but these different things suggest that flowers in garden Y are generally taller than the flowers in garden Z. Doesn't mean all the flowers are, but in general, garden Y a little bit taller than garden Z. We look at workbook page 79. Number 1, a student wants to compare the amount of money 2 local movie theaters make over a 2-week period for the last nightly showing of a particular movie. Following box plots show the data for the amount of money each theater makes over the period. Compare the median of each box plot. So we look at the medians here. So if we look at these, the median on both of these very close to 1,000, and if you look, it's actually looks like it's at the exact same point, which does appear to be $995. And so if we answer the question here, we could say the median for movie theater 1 is about the same as the median for movie theater 2. And if their medians are the same, then we could probably conclude that the amount made is about the same. Or being more specific, we could say about $995.
Oh, that's a lot.
Look at number 2. Box plots display the speeds in miles per hour that 2 different animals run while hunting. Compare the medians of each dot plot, box plot maybe, by completing the statement below. Box plot should have been. Okay. So look at these. So they want us to figure out which median is greater on this one. So animal 1 is between 40 and 41. They're actually going by fifths here. They've really got this zoomed in. They're going by fifths of a mile per hour. 40 to 41. Animal 2 is between 38 and 39. So animal 1 has the greater median running speed. So number 4, Angela is comparing the amount of rainfall over the past month in 2 cities on days when it rained. In city 1, the range is 4 5/10 centimeters. Interquartile range is 1 5/10 centimeters. In city 2, the range is 5 centimeters. Interquartile range is 3 centimeters. So what might you conclude about the cities based on the ranges and the interquartile ranges? One thing to think about when you look at this problem, we've had discussion before with this question that people have said, well, it rained more in city 2. The numbers are higher there for city 2. What we have to do is think about what those numbers mean though. A range and an interquartile range. Really, those are just telling us about how spread out the numbers are. what the variability is, right? We don't necessarily know which city it rained more, which city it rained less. We just know kind of this information about how spread out the numbers are. So what we can say based off of this is just about the variability. We could say rainfall amounts on days it rains are more consistent or less spread out for City 1. Okay, or we could say there's less variability for City 1 than City 2. All right. In other words, the City 2 is a little bit more all over the place with their rain amounts. City 1 a little bit closer to the same amounts whenever it did rain.
I just really don't get that.
Look at number 5. The box plots below show the amount of time 2 farmers spent harvesting many varieties of crops during the past 2 months. What might you conclude about the harvest based on the interquartile range, and explain what the interquartile range describes about a population? So it says based on the interquartile range. I can get the right thing here. Okay, so we're going to figure out the interquartile range for both of these. So for Farmer Adam, if we look at interquartile range, the box ends at 36, the box starts at 24. So 36 minus 24, we've got an interquartile range of 12 for Farmer Adam. Similar idea for Farmer Baxter. The box ends at 43, it starts at 37. We subtract the interquartile range for Farmer Baxter would be 6. So what we need to remember when we talk about interquartile range, it's only the middle 50%. It doesn't necessarily tell us overall. But if we just look at the interquartile range, we could say number of hours it takes Farmer Adam to harvest the crops varies more than it does for Farmer Baxter. And a lower interquartile range indicates less variability and greater consistency. We could say in the middle 50% anyway. Now we can look at this overall. Besides looking at interquartile range, we can just look at the range. Notice Farmer Adam, lowest amount was 20 hours, highest is 40. That's a range of 20. Farmer Baxter's between 36 and 45. That's only a range of 9. So Farmer Baxter is a lot more consistent on the amount of time he spent harvesting the crops. And again, some of that may just be based off of what the weather is doing. If it rains somewhere, maybe it rained where Farmer Adam's at, and the 1 week he couldn't harvest the crops as much because he had to wait till the fields dried up a little bit so his tractor wouldn't get stuck. Okay? It's not necessarily saying that one's lazier than the other one, just based off of these numbers. Number 6, following should be box plots again. I think they're checking if we're paying attention to what they're saying. Following box plots show the high temperatures in degrees Fahrenheit of 2 cities during the previous 10 days. Find the interquartile range for each city. So interquartile range, we're just looking at our boxes again. Where's the box start? Where does it end? Subtracting those numbers. So for Kingman, 78 minus 74, we'd want to work that out to show our work. But when you do that, for Kingman, interquartile range would be 4. For Barstow, we'd be doing 76 minus 63. Interquartile range for Barstow would be 13. Okay. Now, another thing we can look at besides interquartile range, we could look at the overall range. Overall range for Kingman is 10. If we do 80 minus 70 for Barstow, 79 minus 61, Barstow's range is 18. So based off of that, that just gives us a little bit more of the picture here about what's happening. Based off of that, now if you look at part B, now it just says based on the IQR, but would we say the high temperature in Barstow is more consistent than the high temperature in Kingman? High temperature in Kingman is more consistent than the high temperature in Barstow. High temperatures in Kingman and Barstow show similar variability, or the cities of Kingman and Barstow are likely in different states. So the answer for this actually would be B. High temperature in Kingman is more consistent. Again, more consistent because Kingman less varied. Low interquartile range. Also, it had a lower range than what the other one did. Incidentally, just out of curiosity, we looked up the other year about these cities. Kingman is in Arizona and Barstow is in California, so they are technically in different states, but we would not be able to conclude that just based off of these box plots.